The next problem is regarding what die. Okay, now when you throw, so it is said that a die is thrown 8 times. Now, and the occurrence of 5 or 6, when a die is thrown, the occurrence of 5 or 6 is considered as a success in this case. Okay, and what is that we have to calculate? So the first question is you have to find the mean number of success. Okay, fine. Now, and you also have to calculate the standard deviation. Now, let's break down this question. Now, it is said that a die is thrown 8 times. So, that means your n from the question, just gather what all informations you get. N is equal to 8. Occurrence of 5 or 6 is considered as a success. Okay, so that means you can just write as probability of getting 5 or 6. You can denote it by small p. Let that be there. Now, you are asked to find out the mean number of successes. Now, let's define a random variable x, and the random variable x is nothing but the number of success. Okay, so these are some of the informations that we got from our question. Now we will have to arrive at the answer. So first you have to calculate what, find the mean of number of success. That means you have to calculate expectation of x, and then you will have to calculate what, standard deviation. What is standard deviation? Root of variance of x. So these are the two things that you have to calculate. So in the case of binomial, now it is clear that here x follows a binomial distribution since it is something connected with the success. Now expectation of x in terms of binomial distribution is np, and in the case of and you will get your sd as what, root of npq, right? Now since expectation of x is np, you know what is n, you can substitute the value. Now you have to find out small p, that is this thing you will have to find out. So we will consider, I hope you all wrote this. Now I am going back to probability of, to going back to find what is probability of 5 or 6. That is equal to what? What is the probability of getting 5 or 6? Probability of 5 plus probability of getting 6 is equal to what? When you throw a die, that is the probability of getting 5. That is something elementary, right? What is it? 1 by 6 plus this is also 1 by 6, right? So 2 by 3, sorry, 2 by 6, which is equal to 1 by 3. So you got your p as small p. Okay, now small p as 1 by 3, and you get your small q as what? 2 by 3. Okay, now you have to find out expectation of x, which is equal to np, that is equal to 8 into 1 by 3, which is equal to 8 by 3. So this first question is solved. Now the second part. Now the second part is what? You have to find out the standard deviation. So for that, standard deviation SD is equal to root of what? Variance of x, which is equal to root of npq, that is equal to 8 into 1 by 3 into 2 by 3. You just have to put the root over here. Now what will you get? 16 divided by 9, 4 by 3. So this is the answer. Okay, next problem is that if we have two random variables x and y, and they are independent Poisson variables, okay, with parameters lambda 1 and lambda 2, now you will have to find out the MGF of z is equal to x minus y. So in this case, I am going to take, you have to find out what the MGF of z, right? Now what is z? X minus y. So what is MTZ? You can write it as MT x minus y. Now according to the rule of what your MGF, you can write this as what? Since x and y are independent, you can write it as mtx multiplied by mt minus y. Okay, now that is equal to, what is mtx? What is the MGF of a Poisson distribution? I hope you remember that. What is it? Yes, it is e raised to lambda into e raised to t minus 1. So here it is said that lambda 1 is a parameter of x. So we get e raised to lambda 1 into e raised to t minus 1 multiplied by this case e raised to lambda 2 into e raised to t minus 1. So this is the final answer. The next problem we have 1 and 2 are the mode of a Poisson distribution. Okay, find the probability that the variable takes the value 0. Now, it is said that this problem is concerned with the Poisson distribution. So, I'm just denoting it as let lambda be the parameter, and from the question we have that it has two modes. So we know that we have studied that in the Poisson distribution we have two modes and they are lambda and lambda minus 1. Okay, now since it is lambda and lambda minus 1 are the two modes, and we have it is given in the question that it is 1 and 2. Now what we are going to do is I'm going to give lambda as 2. Only then I can justify that lambda minus 1 is equal to 1, which is given in the question. Okay, if you put it in the otherwise, if I give lambda is equal to 1, then what will be lambda minus 1? Yes, you will get 0. So what the question that you have over here, you won't be able to connect with your theory part. So in order to give it a connection, I got as lambda as 2 and then lambda minus 1 as 1. Now I hope it's fine with you. So now our next step is to find out what is that they have asked us. Find the probability that the variable takes the value 0. So in order to find the probability that a particular variable, say x, takes the value 0, you should first know what the density function is. And the only information that you have right now is, yeah, lambda is your parameter. And what is your parameter lambda? It is 2. So from that you have to develop your density function. Okay, now let's develop your density function. What is it? F of x is equal to what is actually your density function? What was it? Lambda raised to x into e raised to minus lambda divided by x factorial. So in place of lambda you can what substitute 2. So what will you get? 2 raised to x e raised to minus lambda divided by x factorial. Now this is your density function. Now what is that you are asked to find out? Probability of x is equal to 0. Right. Now what is probability of x is equal to 0? Lambda raised to, instead of lambda, now in this case it is 2 raised to, instead of x you can write 0, e raised to minus, here also you can substitute the value to e raised to minus 2 divided by x factorial, that is 0 factorial, which is equal to 2 raised to 0 is what? 1. 0 factorial is also 1. So final answer is e raised to minus 2, and this is your probability that the variable takes the value, or probability of x is equal to 0.